Hi guys, welcome back to Math with James. Alright guys, today we have a certain type of trigonometric function to solve. Before we get to these complicated expressions, let's try to look at the graph of the simplest sine x. So let me get the white color for the coordinates. Oopsie, so the axis and the y-axis. And sine x actually repeats itself periodically every 2 pi's along the x-axis. All right, so here it goes. So it starts over here and goes up like a wave and then goes down to the x-axis and then up. Here is 2 pi, and this point over here is pi, and this point here is 0. We're going to use the property of a periodic function to solve this huge expression over here. It's because it's going to repeat itself every 2 pi's. So we only need to find out so how many units there are going to be over here to form the first pattern that's going to repeat itself over and over again. All right, so let's see. F1, actually, we can plug 1 in this original expression over here. So F1 actually is sine pi over 4, right? And for F2, we get sine pi over 2. For F3, we get sine pi over 4 times 3, right? Put the 3 for the numerator. And then F4 actually is sine pi. Sine F8 is sine 2 pi. And then you get to F9, we're going to get that. And we're going to find out that the pattern has already shown up. This gives you 2 pi plus 1 over 4 pi. So that tells you that F1 actually is equal to F9. So the pattern actually repeats every 8 numbers. This original function actually repeats itself every 8 numbers. So now we have 2025 numbers. We're going to need to calculate how many times the pattern has been repeated and how many remains there are going to be. All right, so let's just divide 2025 by 8. So let's do the calculation. Let's put a 2 over here and we get 16, 42, and we get 5, and that's 40, and then we get 25, and then we put a 3 over here and then get a 24. The remainder is 1, which means the pattern is going to repeat itself for 253 times, and that's 1 remainder left. We forgot to do one step. We have to find out the sum of the first eight elements, because that's going to be the same for each repeating pattern, right? So let's just find out some special numbers over here. So F4 sine pi, which is 0. So this thing is 0 over here. And F8, that's 2 pi, is also 0. What about the other numbers? So F2 actually is going to be canceled by F6, right? Because F2 is going to be over here and F6 is going to be over here. So this one actually is 1. This one actually is -1. So they're going to be canceled. The cancellation is going to be the same for F3 and F7 and for F1 and F5. So they're going to be canceled too. So which tells us the sum of the whole pattern within the 8 numbers actually is 0. So no matter how many times we repeat the pattern, the sum is going to be 0. Only the remainder matters, right? So we have 1 remainder over here, which means the final sum of this whole thing actually is equal to the only remainder there, the first element over here, which is equal to sine pi over 4, which actually is equal to square root of 2 over 2. All right, guys, take it easy. I'll see you guys next time.